Hello everyone. In this video, we will be discussing the OT architecture and the major components of optimality theory grammar or short form OT grammar. First, let us begin with OT architecture. So, in OT, as we have already discussed in the previous videos, the main assumption is that the underlying representation is taken or considered as input and the surface representation is considered as the output of a linguistic form. Now, what happens between the input and output, we will see in the architecture. For any kind of linguistic form, we assume that there is an input which is present there in the mind of a native speaker. So, the input has the capacity to be included in the Zen component. Zen stands for generator. In this Zen component, the input is multiplied by having or giving rise to different candidate sets like this. So the Zen component generates the candidate sets, as you can see, candidate 1, candidate 2 and so on and so forth up to candidate n. So it has the capacity of generating a range of candidates or possible candidates which then actually are there in the lexicon in the short form called CON. CON stands for lexicon. Now Zen has the capacity to retrieve or to utilize certain features of the already present knowledge in the lexicon and it generates those candidates on the basis of what is there in the lexicon of a native speaker. So what happens to these candidates then? Now that we have few sets of candidates from the possible input, those are evaluated. EVAL stands for evaluator. Now what evaluator does or the eval component does is that it takes into account those candidates and then evaluates them on the basis of the constraints, and constraints come like this. So for a specific type of input, the constraints are already universal. The constraints are universal. So the evaluator component of OT grammar takes the constraint into confidence and makes use of them to evaluate that set of candidate which is generated by the Zen component. Then after the evaluation process is done, this kind of a constraint hierarchy evaluates those candidates and only one candidate of these candidate set becomes the output. So this is the basic structure of OT grammar. How from input to output there is a mapping, and mapping happens through these three components: generator, lexicon and evaluator. Now we begin to talk briefly about those components of OT: Zen, Con and Eval. Each language has its own constraint ranking. The strongest hypothesis is that constraint ranking is the only thing in the grammar that is language particular or language specific. On the other hand, Zen, Eval and even the constraints themselves are universal. So the Zen component is already there in the knowledge of a person who speaks a language. The eval component is also there because it has the capacity to evaluate a candidate set. And the constraints, already we have learned that they are already universal. The universal constraint component is called CON. If the ranking of universal CON is the only difference between grammars, then all the constraints in CON or lexicon are present in the grammars of all languages. Only the ranking is different. So CON also represents the thing called constraint, and the constraints are there in the mental lexicon. So it has a double meaning actually. These are the three components of OT. So Zen stands for generator, as already stated in the previous slides. EVAL stands for evaluator, and CON basically stands for lexicon. And within the lexicon, the constraint set or the universal constraints are located. CON is a short form of lexicon, but within the lexicon itself, the constraints are present. So the speakers actually have the idea, have the knowledge what actually is the constraint for a particular linguistic form. So this particular component is interesting. CON itself is consisting of two types of constraints, markedness and faithfulness. In case of markedness constraints, these are similar to the surface structure constraint or filters of the 1970s generative phonology, propounded by Chomsky and Halle's monumental work Sound Patterns of English, published in 1968. The inventory of markedness constraints is CON, and it is a substantive theory of linguistic well-formedness that complex consonant clusters are bad. This is one example. So whatever is not a well-formed structure in a language or universally in all the languages is called a prohibition for markedness constraints. So markedness constraints actually prohibit linguistic non-well-formed structures. On the other hand, faithfulness constraints are inherently conservative, requiring the output of the grammar to resemble its input. This is important. Markedness constraints talks about the output structure. It looks around the output and sees if there is something not very well formed structure, then it prohibits that structure. On the other hand, faithfulness decides or looks into whether the output of a linguistic form has the capacity to resemble to the input. If there is a mismatch between the input and the output, then the faithfulness constraints are said to be violated if there is a mismatch. If the output resembles exactly the same as the input, then there is no violation of a faithfulness constraint. Now within the CON component in OT grammar, both the markedness constraints and faithfulness constraints are always in conflict, because markedness constraints favor some linguistic structures over others. They are often in tension with faithfulness constraints, which resist changes to input structures. So these two set of constraints are always in conflict with each other, and this particular tension is called constraint conflict, and it is resolved by OT by ranking of the constraints in a language specific way. The next important thing about the CON component of OT grammar is that constraints on output forms are called markedness constraints, which are distinguished from a variety of faithfulness constraints. Within markedness and faithfulness, we have a lot of or set of different types of constraints. Faithfulness constraints prohibit differences between the input and the output, as we have already noted in the previous discussion. The next important component of generator of OT grammar is called Gen, which stands for generator. What the generator does? In OT, the equivalent of transformational component is called the generator or gen for short. The list of possible outputs, this is important, the list of possible outputs, that means the candidates, supplied by gen for a given input is called the candidate set for that input. The input is usually taken to be identical with the underlying representation of generative phonology. So, look at this carefully. You have an input. An input is always represented within slashes. The input is given to the gen component, and then gen derives certain candidates which are called as candidate sets, and it can be n number of candidates. It can have 100 candidates if it has the capacity. It has the capacity to generate n number of candidates, which is known as candidate set. In the gen component, let us look at an example from English. You are aware of the English plural allomorphy, which resembles certain conditioning factors like voicing assimilation, vowel epenthesis, consonant deletion, etc. So these are the processes which are operative in case of a plural formation of English noun. In English, the candidate set from input, the input is books, will include the results of possible rightward and leftward voice assimilation such as books, where k and s agree in terms of their voicing, both are voiceless. But in the input you can see the coda is k, voiceless, and the z, which is coming from the allomorph or the morpheme, the plural morpheme j, it is a voiced sound. But the possible candidates are generated in a way that both ka and sa, these are agreeing in terms of voicelessness. The second candidate are agreeing in terms of the voiced part. So ga and za both are voiced. Then another candidate is generated by epenthesizing or inserting a vowel, by not saying books but bookas. So swa is inserted here. By deleting consonant, you have book. So there is no za or sa at the end, that consonant is deleted, and various other combinations such as bookas, etc. In bookas, you have a vowel insertion as well as voiceless sa. It will also include the faithful candidate, the one which resembles the input. So this is called a faithful candidate. Faithful candidate means the one which does not show any kind of difference between the input and the output. These diverse candidate set, nearly all of which are ungrammatical, that means unacceptable for a native speaker, are not the final output of the grammar. The final output is determined by how the constraint component filters the candidate set. So this is important. The gen component only generates the candidate sets. Then it supplies those candidates to the eval component. Now, how the eval component will generate or to result in the output structure, that is the most favored optimal candidate, that depends on the constraint ranking, and that is not the job of the generator component. Generator only generates the candidate set. Candidates compete in the evaluation part. Candidates compete to be realization of the sum of some input. For example, books, bookers, books, all compete to be the surface realization of the input books. So what happens? All the candidates tries to win the race. I take the opportunity to introduce you to this term, win the race. Win the race means they want to be the winner of this competition. All of them try to be the winner. Okay. Now, but which candidate wins? This is a question. Now, just quickly look at this summary. Input in this case is books, and the candidate set generated by the Zen component are these. Now what is the output candidate? Who is the winner of this particular competition? That goes to the eval component. Now in eval component, Zen produces a candidate set from an input, and that candidate set is submitted to what is the last component that is called eval or evaluator. Its job is to find out the optimal candidate. Eval does this by applying a language particular constraint hierarchy to the set of candidates. So this is the modified structure. In earlier, you had seen this particular thing. Now we have another component coming into picture. So after the input is supplied to Zen and Zen generates the candidate set, those candidates are supplied to the eval component for evaluation purpose. At the end of the evaluation completion, the output is generated, and output is represented within square bracket because it resembles the surface structure. The above flowchart corresponds somewhat to the input to output derivation through the application of an ordered set of rules for generative framework. So this is the mapping of input to output. So you have the input, then you have the candidate sets which are supplied to the eval component. This is eval. So these are the constraints C1, C2, Cn. So there is a dot dot, that means there are lot of activated constraints which operate at the level of eval component. So all the candidates will be evaluated by each of the constraint, and then look at this, all the candidates will go to constraint 1. But after the constraint 1, this candidate is ruled out. So this does not go to this part. So to the constraint set, out of these 5 candidates, only 4 are supplied. And constraint 2 rules out this one, and only out of these 4, only 2 are supplied to the last constraint. After the last constraint also evaluates these 2 candidates, only this one remains, and the one which remains, that means this has won, this particular constraint, candidate D has won the race, and it becomes the output. The question is for you to answer, which candidate of the English plural allomorphy wins the race in this kind of a structural representation of OT constraint ranking. So give the answer in the next video, or you can post it in the comment box. We will see how you have evaluated the constraints and which candidate you think that it is the output or the optimal candidate in that case. Thank you for watching.